All right. Hi, everyone. Thanks for coming. Thank you. So can you hear me all right with the microphone? So my name is Alekos. I'm a software developer, mostly now trying to launch a startup, which is called 22.xyz. And I'm here today to speak about Portal, which is our first, hopefully of many, product. It's an hardware wallet, kind of like traditional hardware wallets, but specifically designed for use with mobile, so optimized for smartphones. And this is going to be kind of a technical workshop. So the target for this workshop are developers that may want to integrate Portal in their apps. So I'm going to speak not really about developing on Portal, so not really changing the firmware itself, but more like using Portal in existing products. And this is kind of the agenda, so I'm just going to give you an intro about Portal. How does it work conceptually? I'm going to give you a demo with the emulator, so from my laptop. Then show the SDK, and then we're going to use the SDK. You can actually, so Portal is mostly designed for smartphones, but you can also use it with a laptop if you have a USB NFC reader, which I have here. So using that, I'm going to demo the SDK from my laptop, but with a real device. Yeah, so I'm just going to start. This is the presentation that I gave in Madeira, where we announced the product. I'm just going to go like super quick, but so the idea is mobile users need custody. They need a solution that lets them keep their keys safe. And right now, we believe there are not really that many good solutions on the market. So we decided to create one. This is the way, obviously, like a huge oversimplification. But this is kind of where we see the existing hardware wallet market. So we have lots of very secure devices, but not really mobile native. So maybe, yeah, Jade has Bluetooth, but it's a pain in the ass to configure. And then you have really mobile native devices like TapSigner and BitKey. But in our view, they're not really as secure, mainly because they lack a screen. So you don't see what you're signing. It's like a blind signer. You just tap it to your phone and it signs, but you don't know what you signed. And I would argue that kind of defeats the purpose of having an hardware wallet if you're still trusting your smartphone to be showing the right piece of information. So this is what we're trying to build. That's kind of our goal, something that's as secure as traditional hardware wallets, but mobile native. Yeah, the kind of innovation is pretty simple UX and a new way of using it, which is maybe confusing at first, but I think it's pretty comfortable, actually, and I'll show it in a second. There should be a video here. For some reason, it's not working, but it's not really important. We can skip it. So yeah, Portal is based on NFC. So this is actually the size of it. Many people expect it to be smaller. So no, this is the size. It is kind of large because the way you use it is like it's being shown in the kind of animation. So you hold it against your phone. So you hold it in your hand. You put your phone on top of it and you hold it up, kind of like that. So it needs to be a bit big. Otherwise, if it was like super small, everything would hide behind your phone. So you need to have the display kind of sticking out from your phone. And it's based on NFC. So compared to Bluetooth, you don't have like pairing processes. It's just like immediately ready. It doesn't have any cables or batteries. So this is kind of the cool thing about Portal. It's completely powered by the NFC as well. So when you have, now it was not powering on because my phone is locked. But if you have an unlocked phone with an app that can manage Portal, in this case, this is just NFC tools. When you tap it, it's gonna power on, which you probably cannot see, but it's on now. And we also maintain a display and a physical input. So the thing on the right there is a capacitive button, so it can sense when your finger is there. So you can see what you're signing, and you can provide feedback to the device. You can say, yes, I want to sign this, I accept. It's built on BDK, so we're running BDK on the device itself. So anything that BDK supports, theoretically, we can support it here as well. We just need to build like a UX around it. So right now, this is our coded to be a single sig. Very soon, we're going to have multi-sig as well. So we're just kind of developing the UI to register the other keys. So you can register the other XPubs. Later on, we also want to have like arbitrary descriptors that's going to take a bit longer because it's kind of hard to design the UX around it. But it's already supported technically. So the device already supports arbitrary descriptor, complex, smart contracts kind of things, time locks and stuff. And it's completely open source, so you can find on GitHub both the firmware and the hardware as well, if you want to play with it. There's actually a guy that has already built his own boards, so he didn't want to wait for us to ship the real devices, so he got the files on GitHub and ordered boards and assembled them himself. Obviously, it's not something anybody can do. It's kind of hard, but you can do that. It's open source. In terms of software integrations, it would be impossible to make everybody happy, because there are people that want single sig, people want multi-sig, people want more complex, time-locked things. So the idea is we just focus on the hardware and we let other people build wallets. And this is why we have the SDK. So with the SDK, we are helping existing apps integrate the device. The SDK is written in Rust, in async Rust. So it's pretty efficient, pretty lightweight. And then we have bindings on top for Kotlin, Swift, React Native, and Flutter. And it's so easy to use the SDK that I could show all the 4 languages in a single slide. Obviously, okay, it's pretty small text, but using the SDK doesn't really require that many lines of code, because we've put a lot of effort into making it super simple to integrate the device. So it's a few tens of lines of code in total to use one. And yeah, these are the 4 languages we have right now, that we support right now. And this is kind of an outdated slide. So we're working with a bunch of apps. These were the first 4 apps that kind of committed to integrating it, which are Green, Keeper, Bull Bitcoin, and SatSigner. Now we have many more. This was in Madeira at launch, so a month and a half ago. Since then, we've added a bunch more others. But yeah, so this is just kind of a very quick introduction about Portal. It's an hardware wallet. It's designed for smartphones. And now I'm going to start kind of getting into the more the technicalities of the device. So how it works, it's pretty simple. So we have a generic microcontroller. So we don't have a secure element like Ledger, for example. But the fact that we use a generic microcontroller means we are also super open. We don't have any NDAs or embargoes on the code we write. So we can just publish everything. The microcontroller specifically is the STM32L476, which I actually think, I'm not sure, but I think BitKey is using the same chip. So it's just kind of a generic.
M4s are very common.
This is the L4, because this is the low power.
But the ARM port.
Yeah. Okay, yeah. So it's a Cortex M4, yeah.
You could probably port it, you have less supply chain.
Oh, yeah.
Others, you can probably switch to a totally different manufacturer with
Yeah.
with minimal headache.
Yeah, so it's an ARM Cortex M4. It's an STM32L4, so L4 is the series of devices. L stands for low power, because since we're powered with NFC, we're very tight on the power budget, let's say.
And these are known for being very low cost and very general.
Yeah, this is kind of expensive because we have a big one. So we have a big firmware because we have miniscript and stuff. So we have the one we're using as a 1 megabyte flash, and then we divide the flash into banks. So you have one running, and the other one is the spare bank when you do firmware updates. So the firmware needs to fit in 512 kilobytes, which is a lot for embedded, not so much when you run Rust code that was not really designed for embedded in the first place. So we're kind of tight on that side as well. But yeah, no, they're pretty cheap, pretty universal. They're kind of everywhere. So this is kind of the heart of the device, the microcontroller. We have another chip, which is the NT3H2111, if I remember correctly, which is an NFC. This is the chip that deals with NFC, pretty much. So that's really the device is super simple. That's all there is to it. One microcontroller, one NFC kind of communication, and also energy harvesting chip. So this is the device the chip that powers the device. And then we have a display. That's it. And the way it works, obviously, you have a communication kind of channel via this chip that kind of connects the microcontroller and the NFC device, like a smartphone. And through that, we can exchange messages back and forth. So we have almost kind of an HTTP-like protocol. So we send a request and get back a reply from the device. So the phone is going to send a request like giving your status. So are you initialized? Is it unlocked? Is it locked? And the device will reply back with a response to that message. And I'm going to show that in a second. Yeah, so I think I'm just going to start with the demo because I can talk more about the device while I show the demo. And also I'm going to talk about how to run like this demo yourself. So if you want to play with it yourself. So on GitHub, where is it? So this is our GitHub organization. It's github.com/22hw, 22 hardware. And in our GitHub organization, we have the Portal software repo, which is kind of a monorepo. I used to hate monorepos, but I think for what we're doing, that's probably the best solution. So in this repo, we have all the software that runs both on the device and on the smartphone. So the nice thing is that everything is written in Rust, except for the bindings, pretty much. So being in Rust, we can kind of, since we run the same language everywhere, we can kind of share the code between the SDK, which runs on your smartphone, between the firmware running on a device, the emulator running on a laptop. So it's all in this repo for this reason. And if you want to play with it, the best kind of experience you can get is with Nix. So if you use NixOS or if you have Nix, like in this case, I'm using macOS, but I have Nix installed. We provide a flake, which is like a configuration file with all the dependencies, everything you need. So with Nix, you can load this flake, and it's very simple. This is a long command because I need to zoom in a little bit. Can you see my? Yeah. Yeah. So I mean, it's a long command just because I'm using experimental features. You could move this into a configuration file if you want. So the command would be like nix develop. And then you can choose what kind of environment you want. So there are different environments. Just because just having a single environment, it would be huge, ton of dependencies. So I kind of split it up into the embedded development environment, which is a compiler for the firmware for the embedded target. Or you could also get like the Android development environment, which has the compiler for Android. You can use that to compile the Android bindings. Same thing for iOS. So yeah, in this case, I'm just going to use the embedded environment. So I think this should be written somewhere on GitHub. Normally, you would just do nix develop. So this is the command you would run normally. In my case, I have the extra experimental features, whatever. Nix develop embedded. If you do that, it's going to load. It's going to take a while because it needs to download a bunch of dependencies. But it basically creates an environment where you have cargo. So you have the Rust toolchain. Both the native toolchain, so you can compile software for your native, like your laptop, whatever it's running, so whether it's Linux, macOS. And we also have the target for the firmware, so the ARM Thumb v7 target. We have a C toolchain because we need to C toolchain for the firmware because we need to compile dependencies like libsecp, which are in C. We have QEMU to emulate the firmware, so ARM emulator. We have graphics library to show the emulator kind of window, plus tools like to flash the device, etc. So with Nixos, you get the whole environment ready in like a second. Or I mean, it takes more than a second to load, but it takes 1 second to you to just run the command. Here I have everything pre-cached, so it's like immediately available. The first time you run it, it takes a bit longer. Alternatively, we also have Docker images. I'm not showing them because, to be honest, I've never run Docker on macOS, so I normally use Linux. So I'm kind of confused. I don't really know how macOS works. So I don't know how to run Docker images. I guess you can, probably, but we have two images. One is the Portal dev environment. The Portal dev environment is pretty much these two things. So it's like again, like a cargo compiler, Rust compiler, plus the C compiler. So with the Portal dev environment, you can compile the firmware yourself if you want. So you can change the firmware as well. You can recompile it. And then another Docker image is the Portal emulator, which is the thing I'm going to show in a second. And so the Portal emulator normally creates a window. So it's like a native GUI window app. in order to run it in Docker, I came up with this kind of janky solution, which is I spawn a VNC server and I start the window within the VNC server, and then it's exposed to a web client. So if you run this, it's going to print a link, and it says just open this link with your browser. That's going to point to a VNC client that loads the VNC server that has the window inside. And with the Portal emulator, you can just use it, so you can just run the normal firmware, pretty much. You can also run the tests if you want. Or if you combine the two images, and there should be, I think in the maybe firmware directory. No, not here. So somewhere in the GitHub repo, there are instructions on how to kind of merge the two images together, so you can get both the development environment and the emulator just using Docker, so you don't need to install anything else. And so with that, you can like complete the cycle. So you can modify the firmware, compile it in the dev environment, and then load it in the emulator. So you can also run tests of your custom firmware if you make changes. Obviously, it's better if you use the native, like I said, for example, with Nixos, or if you with Nix, or if you manually install all these things, that you're going to get a better experience because you don't have to use different Docker images and mount stuff from one into the other images. But you can get it done just with Docker if you don't want to install anything else. Once you have the whole kind of environment set up, you can run the command, cargo emu, which stands for emulator, -dev. So that's gonna, obviously, again, here I have everything cached, so it takes just a second. In the real world, like the first time you run it, it takes a while because it's gonna compile the emulator, which is a Rust binary itself. Then it's gonna compile the firmware, and you can kind of see it here. So this is first compiling the emulator, then running it. When the emulator runs, it's gonna compile the firmware, but here it was already, there were no changes to the firmware, so it was immediately ready. And then it internally spawns QEMU, so the emulator, the ARM emulator to emulate the firmware. And then you have this nice, very basic kind of UI to interact with the device. Up here you have the screen, so what you would see on the screen. If you click on it, it's the equivalent of pressing the button. So when you need to press the button, you just click on the screen, on the black screen area. And then underneath you have a bunch of buttons and text fields. These are pretty much all the commands, all the requests you can send to the device. So for example, I can send the get info request, and you probably cannot see it very well because it's pretty small, but so I send the get info request, and this is the result I get back. So I have a card status. Card is kind of an historical thing. So initially I was calling this very generically NFC card, even though it's not really a card, but so initially it was called NFC card, so the card status name kind of stuck. So you get back this structure which tells you whether the device is initialized. In this case, it's not. So it's initialized false. Unverified, I'll get into this, I'll get into it in a second. Unlocked, true. When you have an initialized device, it may be locked with a pair code, which is like a secret that encrypts the content of the flash. In this case, it's unlocked. So basically tells you don't need to provide any unlocking code. And network, none, because now it's not initialized, so it doesn't have any network. And we can initialize the device by pressing this button here, so generate mnemonic. This is going to send the generate mnemonic command, and then the device is going to generate independently a new mnemonic, so the device is going to generate its own entropy, and then it's going to show on the screen the mnemonic for you to write down. I will actually change, before going through with this, I will actually change one thing very quickly, because if you run it in this way, it's not going to persist the content of the flash. So it's not going to persist the configuration. So I could go through all the initialization kind of process, and then when I close it, I lose all the content. So there are a bunch of options you can provide to the emulator. So if you give it the --help flag, you can get a list of the options. And really, I guess the most important one you may want to use is the flash file. So if you if you specify this option, it's going to save in a file the content of the flash. So you can also reload it later. And I guess I want to do this because if I initialize it and then I put some funds on it, I want to be able to rerun the emulator with the same flash content, so with the same configuration. So I'm just going to run it with cargo dev flash file. I don't know. Whatever. So now I can go through with the actual initialization. So I can send the generate mnemonic command. This field right here is for the pair code. So I'm actually going to explain that. Even though I'm not going to use it right now, just for convenience, I'm going to explain what it is and how it works. So since we're not using a secure element on this device, we're using just a generic chip. There are known attacks that can extract the flash of the chip, which are not really easy to execute. So you need some kind of sophistication, you need physical access. So somebody would have to steal the device, and then it would need pretty sophisticated hardware in order to execute the attack. But it is possible. It is known to be possible to extract the content of the flash. So if you just store the mnemonic or your seed unencrypted, somebody could theoretically steal your device, extract the content, and get your funds. So if you want, you can use the device in this mode. So for example, if you say, I keep my device in a safe at home, I would say it's perfectly fine to use it this way. So if you protect it like physically, you can use it in this mode. But if you have a device that may be exposed to other people, it's probably better to have this extra protection, which we call pair code, because it effectively pairs the device with your phone. So it's like a secret, it's like a passphrase, like a string of text that your phone knows and can provide to the device to unlock it every time it boots. So the device itself, if you just try to power it on, if you tap it to a smartphone, it's going to say locked, because the content of the flash is encrypted with some secret. And your phone knows this secret, so your phone can provide this secret and can unlock the content of the flash. Here, just for convenience, I'm not going to do it otherwise. Every time I restart it, I need to provide the code. But in like a real-world use case, I generally recommend enabling the pair code. But again, as a developer, that's kind of your choice. So you could either choose to always enable it. You could choose to always keep it disabled. You could give the users of your app the option. So maybe you can have like a default on, but under some advanced option menu, you can disable it if you want. Also, the code actually comes from you. So the device doesn't generate its own pair code. The pair code is provided through the SDK. So you could also generate it randomly, which is the thing I recommend. But if you want, you can also, again, in some kind of advanced menu, submenu, you can give the user the option to provide a custom code. So if the user wants to, it could provide a passphrase that it likes to use. I guess, so the default I recommend is randomly generated, always enabled pair code. So I think that's like the default, that's the best, most secure option. But if you want, you can give these extra options to the user, or if you have maybe some specific use case, like you have a multi-sig with many keys, maybe you don't consider the physical security of each individual key as critical, so you could disable the pair code. Obviously, the trade-off is if you forget the pair code, you cannot use your device anymore, which you can still recover the funds. So the pair code doesn't affect the seed, so the funds are only protected by the seed. So as long as the user has the seed, the user can always recover the funds. But the device itself is like bricked if you lose this pair code. So the trade-off is if you enable the pair code, it's more secure, but it's a bit more complicated even to, migrate to a new smartphone, for example. So I buy a new smartphone, I want to use the same device, I need to somehow get this pair code into my new smartphone. So some apps maybe will synchronize it automatically. I don't know, there are apps that have like encrypted configuration blobs, and so they could use that to move the secret like seamlessly, so the user doesn't even know that it happened. Other apps don't do that. So in those cases, the user would have to manually type in the code in the new app. So that's kind of the trade-off. If you enable it, you have some potential like user experience, not really troubles, but it makes the user experience obviously slightly worse, but you get much more security. If you disable it, you have like a physical better I don't know, device. Like whoever has physical access can spend the funds because there's no encryption there. Anyway, so it was a long parenthesis. In this case, just for the example, I'm going to keep the code disabled because it's quicker. So if I press generate mnemonic, I'm sending the request to generate a new mnemonic. The device is going to generate one, and then it's going to show it on screen 2 words at a time. Because, I mean, it's pretty big here, but obviously the screen is kind of small. So we're showing them 2 at a time so that the user can kind of see them clearly. And the way I would recommend using it is you place the device on your table, place the phone on top, and then you can see the words, you write them down, and then press the button to move to the next page. So you just go through them. If the device were to accidentally power off, because it may happen if you maybe move the phone a little bit, it's pretty tolerant to movement, so it's not like any slight movement will power it off. But if you move it by a lot, or it slides, I don't know, off the table or whatever, the device is going to power off because it's going to lose contact with the phone. If that happens, I can actually show it here. So if I press this, the last button is the reset button. So if I reset it, I just like powered it off and on. And I get the same effect if I close the emulator and restart it, obviously with the same flash file. If that happens, you get this like loading screen, you're like stuck here. With the get info or get status command, you can understand that the user is kind of stuck in this scenario, because if you run that request, you are going to get back this, which says initialized false, unverified. Now, before it was none. Now unverified is some, which means it is there is a mnemonic in there, but it hasn't been verified by the user. The user hasn't got to the end of the verification process, let's say. And false or true means whether there was or not the pair code enabled. So in this case, it's like, yes, this is unverified without the pair code. If it was true, it would mean that it was unverified, so the user hasn't got to the end of the verification process, and there was also a pair code enabled. And now we also have a network, because when we send the request to initialize the device, we specified Signet as a network. So now the device is already in Signet mode. So yeah, so it looks weird. It's kind of the way you would do it in Rust, I think. So in Rust you have optionals, which are either none or some. So that means there is no value or there is some value. Yeah, exactly. So because it's not a Boolean. It's like you have 3 states. You have no, it's not unverified, or you have yes, it's unverified, and then you also have is it unverified with or without the code. So the way it's modeled is whether or not it's unverified. You get it from the option. So if the option is none, it's not unverified. If the option is some, it means yes, it's still unverified. And then within the option, you get a value, which in this case is a Boolean, which is true or false, which is whether there was or there wasn't a pair code. Yeah, it looks kind of ugly. Maybe I'll change that. I don't know. But yeah, it's kind of a Rust thing, I guess. For me, it looks kind of natural because I'm used to Rust. If you're not used to Rust, that may look a little weird. So if you happen to get stuck in this scenario, you just need to send the resume request, which means, okay, resume the verification process. And I mean, by verification, I mean just the user going through all the pages and writing down the words. And it's actually going to start from the beginning because there are no checkpoints, but at least the mnemonic is still the same. So if the user has already, let's say the user was already writing down the words, and then at the 3rd page, this thing happens, the first words are going to be the same. So the user is just going to go through them very quickly, and then it will resume writing them down from whatever point he was stuck at. So here I'm going to go to the end.
Did you feel that you had to do it this way because you're using NFC power, so this thing can cut off?
Yeah. So yeah, it can always happen accidentally. Like you move the device a little bit, it slides a little bit too much. It also depends on some smartphones are not that sensitive, others are more sensitive. So you may lose the connection during this kind of critical initialization process. So there's a similar thing in the firmware update as well, because firmware update, you need to upload a lot of data, and NFC is very slow. So it takes like 5 minutes, I would say, to transfer the whole firmware, which is just half a megabyte. And it could stop at any point. Again, if the phone slides a little bit or the device slides a little bit. So there are checkpoints in the firmware update as well. So if you lose the connection, you restart the update, and it's gonna continue from more or less where it left off. So maybe it's gonna go back a little bit because there are checkpoints at predetermined points. So maybe it got to like 54%, it's gonna restart from 50%, but at least you don't have to start over.
Is this like a standard way of doing things, or did you have to come up with this because it's NFC?
Yeah, I would say it's probably kind of a very specific thing, because I would expect, for example, with Bluetooth, maybe it takes 30 seconds to transfer the firmware. So, I mean, if it powers off, okay, I'll just redo it from scratch. Here it takes 5 minutes total. So let's say you get to 4.5 minutes and it powers off and you have to start over. That is like annoying for the user. So just in order to provide a better kind of user experience, we decided to do it that way. Also, for the mnemonic thing, it's important to really make sure the user gets to the end. Otherwise, let's say I show 2 pages, then the device reboots, and then next time you power it on, the device thinks, oh, I have a mnemonic, I'm ready to be used, but the user didn't get to see the last few words. So you now have a device with a key inside, but the user doesn't have a full backup of that key. So you need something that really kind of ensures you get to the end of the process. And the alternative would have been, until you get to the end, I don't save anything, but then you would have the problem of the user writing down 10 words, then it powers off, and then when you restart it, you get 12 completely different words. And so the user would have like a piece of paper with 10 words, would have to throw it away and start over, which is also annoying. So this is why we have this kind of checkpoint thing. From the beginning, the mnemonic is like set in stone, so the mnemonic is not going to change after you generate it once. And then we just make sure the user gets to the end of the process before moving on to this like ready state. This is like the normal state. So when it's unlocked, this is where it's at.
Is there a reason you couldn't store the page they're on and just restore it?
No, I could do it. So I think I was being too paranoid about the flash write cycles. So I don't want to keep writing to the flash, just not to burn it off, but it's probably fine. It's like 12 words, it's like 6 pages, so it's probably fine. Yeah. So maybe with the firmware update, I'll change that. So I could make it that.
What's your model for how many writes cycles you allow?
And I think there are like hundreds of thousands probably. I'm just very paranoid. Yeah. No, it's probably fine.
You can cycle them.
Yeah, that gets more complicated, but yeah, technically you could shuffle things around. So now we have like a fixed kind of layout. So the
Like a circular buffer, like stuff like that. So that
yeah.
make sure that wraps background ID.
Yeah, so I think it would get a bit complicated there because, so the STM32, you have 2 kilobyte pages, and when you want to write something, you need to erase the whole page. So the way I'm doing it now is so it's 512 kilobytes, so it's like 255 pages, and I'm using 254 pages for the firmware, which needs to be contiguous, because otherwise you have holes in your firmware, and then the last page is for configuration. So in order to do what you're describing, I would have to like break the firmware into 2 parts. So I have like the configuration in the middle, which is kind of complicated, I guess. But I mean, it's probably fine. So I'll probably add that. So every time the user confirms a page, I will save that page. I guess one of the benefits of doing it this way is if the user wants to go back and it's like, wait, what was the 5th word? You can do it this way, because you remove your phone, so the device is going to power off. You put it back there, and it's going to start from the first page. So you can kind of recheck the ones you've already maybe written down.
Can you just
But
store an event like
can you? Sorry.
you could store like the enum page they're on and then you
Yeah. So the problem is, since there's only one button, so you don't have like advanced input. You cannot go back and forth. You cannot do. So there's no way to go back in the pages. So that's why I was saying, with this kind of model, if you reset it, it's going to start from the beginning. So you.
just start from
Yeah.
word 1
Yeah.
and just make sure I don't overwrite. So you're
Yeah.
doing like a lower resolution of what I'm describing.
Yeah, I think so, yeah. But yeah, anyway, so that's the kind of initialization process. I'm going to mention at some point we will come out with an app to do the initialization ourselves. So at some point, probably as developers integrating this, you will not have to deal with this, but we're not ready with the app yet, so now you have to do it. And the benefit is you can also initialize it the way you want. So you can initialize it as with or without the pair code and whatever, depending on what your users want. So now I have the device ready. I can run another request, which is a public descriptor, which means give me the descriptor, obviously just with public keys. There's no private keys inside the descriptor that it exports. The user needs to confirm this operation because it's a sensitive privacy kind of thing. So the user presses the button, and you get back the two descriptors. So you get back the external and internal descriptor, which
What do they look like?
I'm going to show them here, I guess. So yeah, now it's hard-coded to single sig. So it's a SegWit single sig kind of thing. So I'm gonna.
Can you decide what type of addresses that you use?
Not right now, but yes, it's gonna come. So it's gonna be like right now you can only generate a key and it automatically wraps that into a single sig. Then it's gonna be more like you generate a key and that's the first step, and then the second step is telling the device what type of descriptor you want. So it's gonna be initially just single sig or multi-sig. So you generate the key first, and then you're like, okay, I want you to be a multi-sig, and you are the third key, and these are the other two, for example. Or you could say, okay, this is your key. Now I want you to be a single sig but legacy, or single sig taproot, for example. So that's gonna come pretty soon. And then later on, we're gonna have completely arbitrary descriptors, which is gonna be even more complicated. So then you could say, this is your key, and this is the full descriptor, and you are this key right here, and these are the other keys, and these are the time locks. That's a bit more complicated.
So there's going to be an app that's associated with this to do the more complicated stuff.
Yeah, so it's all going to depend on the app. So some apps maybe will integrate it just as a single sig device. So it's going to be, I guess the way it's going to be implemented is, right now you only have generate mnemonic, like this call. It's going to be like generate mnemonic first, and then you have another request you can send, which is set wallet type, whatever. And you can set it as single sig or multi-sig or descriptor. Some apps will not even let the user choose, obviously. Maybe some apps will just be that single sig, that's the only thing we support. So they can kind of hard code it to single sig. Other apps maybe will give the user the option of what do you want? Do you want a multi-sig? How many signers there are? What are the other XPubs and stuff like that. So now I'm going to deposit funds into this wallet. I'm going to use BDK CLI as a wallet on desktop, which I should have here. No, here. Yeah, so I'm going to use BDK CLI just to monitor the descriptor, so I can see the funds, I can generate addresses, I can create transactions, all from my desktop, and then I'm just going to give the unsigned PSBT to the device so that it can sign it. So let me do like this. Okay, so these are the two descriptors, and then it's like BDK CLI, it's wallet. Yeah. Okay, so here I can get an address from this wallet. I think I initialized the device as a Signet device. BDK CLI is in testnet, but it should be fine because the prefix is the same. So the device is not gonna know it's running on testnet and not on Signet. Yeah, so now I have like a wallet on my desktop. I can generate addresses. I can sync to get the balance, to like synchronize with the blockchain. So to figure out if I have any UTXOs belonging to my addresses, I can get the balance, which should be empty. So I'm going to deposit some funds So I guess does anybody have a testnet wallet on end? Otherwise, I could send some funds from another portal, but it takes a second longer. So
I have some funds, but I have to sync the block.
it's okay. So I'll just use it with the other portal. So let me actually.
Testnet faucet.
Oh, right, yeah. Yeah, I don't use faucets because I always need them multiple times and they only give you funds the first time, but I think it should be fine. I think it's the IP usually. Yeah. Oh, why? I haven't used it. Oh yeah, I mean the Wi-Fi. Okay, somebody's. Okay, no, I can send funds from the portal. It's gonna take. What? Yeah, I don't have it here because I don't use macOS. This is like empty, like almost stock macOS. But no, I think I can do it. QR code. Okay. Is it?
That's the one I use. They're not stingy or anything.
It's the one I was using, right? Oh no, okay, this is a different one.
There you go.
Okay, let me try with this one. Thank you. Oh, okay. I think it's. Let me check. Oh, how are we doing on the halving? 4 blocks.
4 blocks.
Nice.
Oh yeah, testnet might be full.
Yeah, it doesn't, but it should. It's crazy. I think it should work even if it's unconfirmed. I can spend it even if it's unconfirmed. I just need them to actually send me funds.
I didn't realize the time of the workshop until
Yeah.
this morning.
They're practicing their root degeneracy.
Yeah, they're practicing.
Oh, okay. I have 2,000 satoshis. A very, very small amount, but okay. So I have 2,000 satoshis. This is untrusted pending. It basically means it's unconfirmed, but I can spend them already. So I'll try to create a transaction, sending the funds back to the same wallet, just to because it's quicker. So I get a new address, and then it's I think it's create tx to and let's do send all. Okay, so this is PSBT, unsigned PSBT, obviously. We can inspect it with this website here. I don't know if you've ever seen it. It's actually a thing I created a while back, which is not maintained anymore. So I should update it, but it's beep174.org. It's like a PSBT explorer. So you can like see what's inside the PSBT. And you can see right now there are no signatures, just an empty, unsigned PSBT. We can give this to Portal, and we can run the signed PSBT request, which is going to show on screen. So what Portal shows is all the outputs except the change, because it can figure out, oh, this is my change, so I don't need to confirm it. So it's going to show in order all the outputs except the change plus the fee at the end. So obviously there's a fee, so I had 2,000 satoshis. This is 1,000. Yeah, there's this weird thing I definitely need to update, that it skips the trailing zeros, which is very annoying. It's just a Rust Bitcoin thing. I guess I'll implement my own kind of serializer to display the number. But so this should be 1,890 satoshis. You can see the address. You have the full address scrolling left and right, and then you have in small the first and last 8 characters. I'm thinking about actually switching them because in the end, most users probably care about the beginning and the end of the address. I've seen services like Kraken. I think they don't even show the full address anymore. They just show you the beginning and the end. So I was thinking about you have in big beginning and end, and in small the full address. So like if you really want to, you can just squint at the small print and you can see the full address. But
It'd be useful to show the fee.
it's at the end. Yeah. So you confirm the outputs. So this is the first and actually only output because the change. Oh, there's no change here, I think. Yeah. And at the end you get the fee. So at the end of all the outputs, you confirm the fee.
And is there a button on the portal that you're pressing when you're doing?
Yeah, so now for the emulator, I'm clicking on the black section, which is equivalent of pressing the button on the portal, on the real one. So yeah, now I got back the sign PSBT, and I can actually show it here. Well, it's a bit bigger, which is a good sign. There's probably something more inside. And yeah, now we have a partial signature. So we have a signature from the device. We still need to finalize it, which means constructing the witness, which BDK can do. So it's like, it's finalized PSBT. Yeah, it's finalized true. So it means the transaction is signed. We have all the signatures we need. Again, we can kind of double check here.
Is that a base 64?
Yeah. And we have the final script witness, which is the full like witness that goes into the transaction. So now this can pretty much be broadcasted. So with BDK CLI, I can do that as well. And it should be gone. Okay, so this is how you make a transaction with Portal, with the emulator. So now, I don't know, how much time do I have? As much as I want. I have 4 blocks, okay. Nice, that's a good answer. No, I'll keep it quick. So I wanted to show the SDK a little bit. Maybe I'm not going to do a demo of the SDK. I'm just going to show kind of how to use the SDK. So we have a page in our wiki. So if you go to 22.xyz Portal Software, you go to the wiki. We have this page about the integration, so about integrating Portal. And here we describe kind of in detail all the API, let's say, or the API calls you can make. I wanted to show you why the SDK exists. I can show this with the emulator, actually, because the emulator is also emulating like a real NFC communication. So if you put it in like debug mode, so it was emulator. Yeah, so here you can see like the communication going on between the emulator and the device. So these are the messages in this case, my laptop, let's say, is sending, and these are the replies from the emulated firmware. So these are the actual commands that you would send over NFC. So for example, 30 ed is 30 is the read command. Ed is like the page we want to read because it contains a special register which tells us if we can write something to the buffer of the device, which is like this register here. So this means, okay, you can write. So then we run the write command. We write 64 bytes chunks, 64 bytes at a time. And just these few exchanges, this is just to handshake. So this is just to establish a secure encrypted channel. This is even before you try to send any command. And then if you send commands like, I don't know, get info, you need to check whether you can write, then you write the command to the buffer, then you need to check whether there's something for you. So this is, you can see this value change. So this means there's something I can read. So then I perform a read, I get all the content, all the buffer content. Then this is encrypted, so I need to decrypt it. So why the SDK exists, you could re-implement this if you wanted to integrate Portal, but it's painful. It's very annoying to implement. So as the SDK implements all of this logic for you and just exposes a very kind of high-level API. Yeah. Yeah, so this is running in the emulator, but it's emulating the actual NFC messages you would send to a real device. So these are, for example, I can show you here.
So this is an SDK for NFC communication?
Yeah, not just NFC. So it's a SDK to communicate specifically with Portal over NFC. So it's not just a generic NFC library. It's just specific for Portal, for the way. Yeah, if you're interested, you can check. If you open the data sheet of the chip I'm using, you can check, for example, the NFC commands. So read is the 30 hexadecimal command. So this is why you see like, what is it? Like 30 ed means I want to read.
Oh, this is the I square C bus.
This is the NFC. So this is from the NFC side. And then the device also has an I2C bus.
That's how it talks.
Yeah, so that's how you talk with the NFC. and then the device talks via the IC talks via I2C to the microcontroller, and you have you have a 64-byte buffer where both can write and read from. So you have to coordinate who can write. Only one can write at a time, pretty much. So you have some coordination going on. Alpha duplex. Yeah. So this is why you have to read this register, which is going to tell you whether you can write. You have flags. You can be like, okay, I can write. So then you write. Then when the other side reads, it updates the value in the register. So both sides are like polling the register, and the microcontroller would be like, oh, the NFC side has read the message. I can write the second chunk, or vice versa, depending on the. Yeah, I mean, it's nothing super complicated. Obviously, like pretty normal, I would say, for low-level stuff. I don't know if there are any full duplex chips. So the one I'm using, I chose it mainly because it's ISO 14443A, which is as far as I know, it's the most kind of universal standard. It's also the one that credit cards use, apparently. I think it's like very short range. There's also another standard, which is NFC 5, NFC V, which is ISO 15, this 15 whatever. Yeah, I mean,
so you just got like a SPI chip, you would instead of use SPI instead of I2C, then you got full duplex and much faster cost.
but I think so. So the problem is you only have that one buffer, and you need to share it. So I guess there could be another chip that has two buffers. So one is writing to one, the other side is writing to the other. As far as I know, there are. Yeah. As far as I know, there are no chips like that. So I was mentioning this ISO thing because there's another chip from ST which does the same thing.
It's such a bottleneck, I would think, over time.
Yeah, I guess, I mean, NFC, maybe NFC is not really designed for transferring like massive amounts of data, I guess. So, but yeah, anyway, so going back to the point, you could write this, obviously, if you want, and the protocol is somewhat documented, not the best documentation, but it's somewhat documented, but it's annoying. So we have the SDK. With the SDK, what you do is it's async. So I don't know how these are called in other languages. In Rust, you call them tasks. So it's like a thread, but like a light thread, like a green thread kind of thing. So you need to launch a task that just runs pretty much this loop. So you tell the library. So SDK is an instance of the library. You construct an instance of the library like at the beginning of your app, when your app is initializing. Whenever you see a new device, so a new NFC tag, you tell the library, hey, this is a new tag, because the library need to know whether because this could happen, again, if the device moves a little bit and then comes back, you need to tell the library that the device reset, as reset in the meantime. So you tell the library, oh, there's a new tag, and then you just start this loop, which is you call poll on the SDK instance, and this is going to give you a message to send, which is just a binary blob. Just send this message over. You send the message, you get back a response, and then you tell the library, hey, this is what I got back. So this is, and you have a message index kind of thing to keep track of which message you are replying to. So this is kind of the only thing you need to do, just drive this loop forward. Since it's async, it's like, while there's no communication going on, it's just going to be stopped here. So it's not really consuming any resources. So first thing you do is this. You launch this kind of task. And then the SDK is actually thread safe. So you can use it like in parallel from many different places. So you have one task kind of driving this loop forward. And then from another task, from the UI task, whatever, you can make calls like get status, which is the call that is going to give you this structure back. So you always need to have that loop running, obviously, because that's the one that actually drives the communication. But then in other tasks, you can make the actual calls. And yeah, I mean, I'm not going to go through all of them, obviously, because there's quite a few. But these are all the APIs you can find. So you can get the status of the device. You can unlock the device with a pair code, generate a mnemonic, stuff like that. And this is all kind of documented here.
What kind of software are you looking for Portal as far as like what type of what are some good ideas that are out there for people that
Yeah, so I would say in general, like any mobile app, you could also do desktop with the USB readers like this. So technically you can use it with a desktop, but it's with a laptop, desktop, whatever, but it's kind of annoying. So I would say the targets are mobile apps that in some way deal with on-chain transactions. So mostly wallets, just pure wallets, but you could also have, so for example, we've been speaking with an app, I don't remember the name right now, which is like a lending thing. So you have, when you get a loan, you deposit Bitcoin in a multi-sig, and I don't know exactly how it works, but so they need to create this Bitcoin transaction. You need to deposit in the multi-sig, you need to withdraw from the multi-sig, and they wanted to use Portal to have more security. So that's not really a wallet. It's not something you use to spend to actually send money to anybody. It's just a lending thing. But they wanted to integrate Portal for that reason as well. You could also have like inheritance protocols. So again, not like wallets you use to spend and receive daily, but more like wallets where you just deposit funds and you just like a long-term kind of cold storage thing. But on mobile, if you want to have more security, you can integrate Portal. So I guess there are maybe even use cases where it kind of combines with Lightning. So for example, you could have an app which has a Lightning side. I would say, so the Lightning side, you have hotkeys. So you have keys on your phone. You can actually make payments easily on the go. And then you can have a vault side of the app where you have funds on-chain protected with the Portal. And then with Portal, you can, I don't know, authorize refilling your channels. So you're running low on funds on Lightning. With Portal, you authorize putting, like splicing in some funds. So any kind of app that deals with Bitcoin transactions, I guess is in scope.
Escrow?
And
Maybe escrow stuff.
yeah, escrow as well. So the hardware is very generic right now. Like in this moment, is hard-coded to be single sig. Very soon, it's gonna have at least multi-sigs as well. And then later on, when we're gonna have full descriptors, then you can really make like complex arbitrary protocols. I mean, you can already sign transactions for complex protocols. It's only that the device is not going to be able to kind of understand them. So it's just going to show you, for example, it's not going to be able to understand what's the change output. So yeah, but yeah, I guess there are many potential use cases for it. Yeah, and I think the halving is happening soon. So I'm not gonna.
Block away. So
Okay, so let's close it down here. Let's wait for the halving. Okay.
well,
You
thanks so
mentioned
much.
it's a pre-order now. When's your estimated delivery?
Oh,
Estimated delivery probably July, August, I think, something like that. Yeah.
Beer's ready.
All right. Thank you for coming.